Hi, my name is Chris Freeman. I'm going to be talking to my students today about Earth systems and resources. This is the second component of my Earth systems and resources review for their AP environmental test. So this should be a graph that looks familiar to everybody, but I just want to finish talking about it in terms of seasonal variability and the overall trend of increased carbon dioxide into our atmosphere. So because we have Earth's tilted and the sun is hitting different parts of the Earth with different strengths of concentration at different times. During the winter solstice, we have much more sunlight getting towards the southern hemisphere than we do the northern hemisphere. As a result of that, the leaves fall off trees, and since we have more trees in the northern hemisphere, they're not being able to photosynthesize and absorb carbon dioxide as much. So we have a small spike in carbon dioxide seasonally, and then during the summer solstice, we have much more leaves back on trees, and that's absorbing carbon dioxide, causing that small drop to happen. But because we have more and more use of carbon-based fossil fuels, with hydrocarbons being burned, we see an increase overall, despite the up-down variability of carbon in our atmosphere year after year, year after year. All right, so that's that. Let's move on to another topic that's going to be important for you to be aware of for the test. This is just a quick website that I pulled up to show you El Nino and the Southern Oscillation. So it's important to be aware that we have our global wind belts that are caused from Earth's uneven heat distribution. We have Hadley cells that are associated with the trade winds. And the trade winds are actually so constant that they're holding back this mound of warm water in the Pacific Ocean. And during normal years, the trade winds are sort of defying the pull of gravity to have this mound of warm water in our oceans sort of spread out. And the trade winds were operating normally, but every once in a while, every 3 to 7 years, approximately, but you can have some in even shorter or longer intervals. We have an El Nino event, and this is when the trade winds are too gentle or they stop for a little while, and this huge mound of warm water then can just work with gravity and spread out across the South Equatorial Pacific. And because it's so warm, it blocks upwellings. It artificially lowers the thermocline over by Peru, and it is warm enough to change atmospheric circulation patterns where we have certain rainfall events that would normally take place. Oftentimes they can be shifted. And as a result of that, you can see flooding in areas that typically would have drought. You can see more drought-like conditions in areas that typically have more flooding. And it really affects the Peruvian fishing industry with their anchovies. They just don't have the upwelling there to support that fishery. And so we have these examples of this trauma that occurs with flooding and drought and upwellings being reduced. And we have warmer conditions in the United States during El Nino events. And then La Nina is when the trade winds start to build their momentum back up and push this warm flowing body of water back into place, back to normal, and then we begin our normal years again. And so that's El Nino Southern Oscillation. It's this cyclical pattern that's really been being driven by these trade winds and the trade winds collapsing. So that's an important concept. Let's jump to another important concept, just talking about water. So we have water that you need to be aware of just globally. We think, oh, water's a cycle, so we don't have to really worry much about how much fresh water we have to drink. But it's important to recognize that the bulk of our water is salt water. The vast majority, 97%, is found in our oceans. Then we have ice and snow as the lion's share of our fresh water. Permanent ice and snow really stores a lot of our fresh water. And so if we think about climate change, we have an obvious correlation with something that can affect the storage capacity of our water. And then we have groundwater in lakes and rivers is a very small percentage of the overall water. And so when we think about, geez, we have permanent ice and snow that helps fill, as that melts, the groundwater in lakes and rivers, and is good recharge. We just want to be aware of the small amount of water that's available for drinking. It's also important to be aware that water in our atmosphere is the number one non-anthropogenic greenhouse gas. It's the number one greenhouse gas, period, in our atmosphere. It's important. It can create clouds that can reflect sunlight away. It can just be water vapor in our atmosphere, which will add to warming. So it's a really important thing to be aware of that often comes up on the AP environmental exam. And it's also worth pointing out that water, in terms of agricultural use, the amount of water that we use, 70% of it goes to agriculture, 70%. So if we think about ways that we can conserve, if we stopped eating meat, for example, stopped growing and harvesting meat, then we could reduce the amount of agricultural water use. I'm not saying that we all should, but just being aware of things that we could potentially do to have a more sustainable planet. And 70% of our water consumption comes from agriculture. That's hugely important to be aware of. And what are some strategies to reduce that? And then we have 20% that comes from industrial use, and only 10% is domestic use. So, sure, you can take shorter showers, not keep the water on when you're brushing your teeth or shaving, but at the end of the day, you're only affecting that small 10%. So the best focus would be to focus in on that 70% to make real dramatic changes in our water use, maybe using drip irrigation or trying to think through more water-friendly crops, not eating as much and growing as much meat that relies on growing a lot of other crops to feed them and using that water and so on and so forth. All right. So let me look and make sure I'm covering enough here. We've gone through fresh water. So salt water is important in agricultural practices because of evaporation. You can actually end up having too much salt getting onto soils from evaporation from irrigation runoff. And so bad farming practices can lead to having to abandon your farm because there's too much salt in the soils, which is important to be aware of. We can also have bad farming practices lead to desertification, where you have the top layer get so hard packed that water has trouble getting into it, and you have more surface runoff there. So those are some important issues there, and you want to be aware of, say, drip irrigation and other things that can reduce water consumption and be better farming practices. So let's talk about the rock cycle and jump into this image that I've pulled up for you. So it's important to know the different processes of change that can go through in this evolving cycle of rocks. It's also good to have some rocks as examples that you can use for the test. So let's look at some. Right here we have sedimentary rocks. We have conglomerates, which are basically just large and small rocks smushed together. That may be a good example to remember, but not super important. Sandstone, all these are softer rocks, so they're a little bit more porous. Sandstone's a great example of something to remember to use in this example. And shale is also a nice important one to know as well. But over all of the sedimentary rocks, I would say 2, limestone and coal are the most important. Limestone because it is made of calcium carbonate shells, which is super important, which we'll get into in a minute. And then coal because we use it as an energy resource. So knowing the different stages of coal is going to be very, very important for sedimentary rock examples, and more on this in a minute.